Oh, sir, I need to find physics now.
Look,
Sorry, sir.
we are
Uh,
we are talking
we will be
about
beginning.
atomic physics, huh? So atomic
Yes, sir.
physics means it's talking about atom. Though
It's chemistry.
Cambridge, though Cambridge gave topic 27 later, but according to my opinion, we should start topic 27 first because it's giving the idea about atom. Okay, nucleus,
Yes, sir.
atomic model. So if we finish this one, then it will be easier for us to continue with 26 easier.
Okay, sir.
And it is also smaller topics. Okay, it is only 4 pages. 26 is 17 pages notes. This note is made by me, so we are covering here all the learning outcomes.
Yes, sir.
Look, we are having,
Sir, আরেকটু zoom করা চলো।
yeah, we are having here structure of atom.
Yes, sir.
Structure of atom in terms of nucleus and electrons. You know it. In atom, we have
Nu-
nucleus
uh,
and
Nucleus, which consists of
yeah, around the nucleus we have
neutrons and protons, and
hmm,
in outer shells means there are shells-like structure, which is created by the moving means movement of electron, and in O level, each shell
yes,
second and
and
further contains 8 electrons.
yes, and we have also some other ideas like the neutrons and protons staying in nucleus. Neutrons are neutral; they don't have any charge,
Yes, sir.
and protons they have
Sir,
positive charge.
sir,
Yes,
is it true that during means when a star explodes, means on that time electrons and protons get in such a huge pressure that they combine to form neutrons?
no. What happens in stars? Two hydrogen nucleus they combine together to form a
To form
helium.
helium.
It's not about electrons,
Fusion.
it's about the nucleus. That's why it is nuclear physics. That's why it is nuclear reaction.
Oh, so we will be studying about neutron, I mean nucleus.
Yes, yes. So
Okay, sir.
the whole atomic physics is dealing with the nuclear reactions. That's dealing with nucleus. Okay.
Yes,
So
sir.
we have proton positive charge in the nucleus and electrons are negatively charged. Proton and neutron they have almost the mass almost same, right?
Yes, sir.
And electron they are very lighter. So we have these values here and structure here. Whatever I discuss is available here. I think we do not to read more, right? You will read it and understand it. Then we can go fast. Is it clear?
Yes, sir.
Okay, now we have one experiment, that is alpha particle scattering experiment. What is the purpose of this experiment? To know the structure of atom.
Alpha.
Uh, to know the structure of atom, the scientist Rutherford with his two assistants Geiger and Marsden, they performed this experiment, and after performing this experiment they found these observations. Okay, They did the experiment using the gold foil, and they uh, gave alpha particles to go through the gold foil atoms. Okay, so that they can get this observations. What are the observations they got? You see the diagram. Look,
Yes, sir. I can see the diagram.
yeah, I think you have this idea also before. Uh, this alpha particle is scattering. You got this idea before
No,
in
sir.
previous classes? No?
No, sir.
Okay, look, this is showing you only one atom. Okay, how alpha particle is going through one atom, and you see most of the alpha particles are going straight. Okay,
Yes, sir.
most of the alpha particles are going straight inside the atom. Why it is? Because alpha particle. What is alpha particle? That one also you should know, as you don't have any idea before. Alpha particle means is containing two protons and two neutrons. Okay, in alpha particle we have
Means
two
helium.
protons. Is nucleus of helium without any electron. Okay,
Sir, then
similar
what
to
happens to the electrons?
without any electrons. It is only containing two protons and two neutrons. So it's similar to nucleus of helium. Okay, so
Yes,
alpha
sir.
particles, as it has two protons and two neutrons, we understand that it has positive charge, right? Two
Yes,
positive
sir.
charges. So we can say that alpha particle is positively charged, right? And this information will help us to understand the experiment. Look, most of the alpha particles going through the atom undeflected. This is our first observation. Okay. Now, can you read the second and third observation?
Yes, sir. Around 0.14% of the incident alpha particles scatter by more than 1%. Sorry, is it
One
1% or
degree.
1 degree?
Hmm.
Okay, sir. Scatter by more than 1 degree.
Hmm.
Around 1 in 8,000 particles deflected by more than 90 degrees. This observation led to many arguments and conclusions which laid down the structure of the nucleus model of an atom.
Okay, so
স্যার তার মানে কি যে মডেলগুলি আমরা এখন ইউজ করি নিউক্লিয়াসের মানে অ্যান্ড অ্যাটমসের সেটা কি এই এক্সপেরিমেন্টের কারণে আসছে?
yes, yes, this is the most authentic, and it is the modern basic theory of atom is giving by this experiment. Okay, so this is very important experiment for understanding the atom structure. Now, look here we are having two nucleus. Huh? Here is one nucleus and another nucleus. So, uh, in this diagram, we can understand it more easily that most of the alpha particles they are going undeflected. Okay, is it clear? And
স্যার
uh,
once again please.
yeah, most of the alpha particles are going undeflected. Undeflected means they are going straight. They are not bending.
And which are not?
And which are not, you already read two more
Okay, those
observations.
are,
Yeah,
yes sir, those are alpha particles.
yeah. All are alpha particles. These are all alpha particles. And only this is nucleus. And these are also alpha particles. The arrows, all the arrows are shown. They are all alpha particles. Okay.
Just
Only
which are
this,
deflected and non-deflected.
yeah. The I uh, I used one term that is undeflected, right?
Yes, sir.
So these are undeflected, that means going straight, and which are deflected or
So why
deviated.
do they deflect?
Deflect means deviation from their line.
But what is the reason behind it?
Okay, what is the reason behind? We are going for that conclusion. Why?
Okay, sir.
Okay, from this experiment, Rutherford concluded that. Can you read these three conclusions?
Yes, sir. First conclusion. Since most of the alpha particle passed undeviated through the gold foil, the majority of the space occupied by the matter is vacuum. The majority of the space occupied. Okay. As a few alpha particle got deviated through small angles, there must be some positively charged particle in matter, which repels the alpha particle strongly, causing deviation. Hence, the center of the atom is positively charged nucleus.
So is it clear to
Oh,
you
yes, sir. The
that
new
we know that
alpha
alpha particles,
particles
we know that
as alpha.
alpha
Okay,
particles are
sir. You sir.
positive, right?
Yes, sir.
So they are now repelled by the nucleus. That is our observation, right?
Yes, sir.
First, uh, first one we understood that most are undeviated. That means mostly the atom is empty, right? Nucleus is staying in a
Yes, sir.
small place in the center. Now, the second observation is giving us the idea that the nucleus must have some positively charged particles, right?
Yes, sir.
That's why our alpha particle is repelled by those positive charges. Is it clear? We don't know
Yes, sir.
what it is. When we don't know means when they got this observation, that time they did not know that what are available inside the nucleus, but they understood that there is something with positive charges. Is it clear?
Yes, sir.
Okay, now the third observation.
Sir,
Yes,
from those nucleus, the alpha particle were deviated. Did those atoms have means nucleus were surrounded by electrons?
of course there is electron.
So why didn't they attract the electrons?
Very good question. Electrons, they are very tiny, right?
Yes, sir.
And they are you see there are lots of alpha particles are coming, right?
Yes, sir.
So when we are focusing to the nucleus, that time as the whole atom, you see alpha particle, then nucleus, they are in a very small space, right?
Yes, sir.
So when they are going through the atom, we are now thinking that electrons, uh, they are in a tiny place, it is a small space, but if you compare with the size of the nucleus, size of the alpha particles, and the position of the electrons, they are very far away, right? from the
Yes, sir.
from the position of the alpha particle, from the position of the nucleus, they are very far away staying. So uh, they are going, but they are not affected by the electrons. For this reason they did not bring this discussion here. Is it clear?
Yes, sir.
Okay, then the third observation.
As a very small number of alpha particles got deviated through large angles and re- retraced their path, the size of the nucleus must be very small compared to that of an atom. The nucleus must be very heavy, hence center of an atom is massive nucleus.
So this one, you see, when it is coming directly, okay, almost straight to the nucleus, then they are deviating more than 90 degree, right? Our observation.
Yes, sir.
This one, more than 90 degree. So, and which one is going straight? That is returning back.
It's 180 degree.
Yeah, they are showing one, but it's not only one. Lots of, right?
Yes, sir.
Okay, now why it's happening? Because the center of the atom, it it contains almost all the mass of the atom, right? And if you
Yes, sir.
compare the if you compare the mass of gold atoms nucleus, gold is a big atom, right, with many
Yes, sir.
protons and neutrons. So in comparison to alpha, it's very massive, isn't it? There is
Yes, sir.
one thing that it is positively charged. For this there is repulsion, and again it is massive. That's why if it is going very close to the nucleus, then
It got
because
deviated.
of this mass, there is deviation is more than 90 degree, or it's going back, returning back. Is it clear? Returning back means it is 180 degree.
Deviated. Means
Returning back means,
180 degree deviation.
yeah, 180 degree. Look, if it is coming and going back, then it is 180 degree. Okay, more than 90 degree means it can be 100, 110, 20, then till 180 degree. So these three
So what about
conclusions.
iodine?
What about?
Iodine, because they are as large as gold, but they are negative in charge.
If you are saying iodine is negative in charge, that means it's losing one electron, right? Or
Yes, sir.
gaining. It's gaining one
Yes, sir.
electron. That is negative
It
charge.
is getting
Yeah,
reduced.
chlorine also negative charge because it's gaining electron. Now we are talking
But sir,
about
that
the,
is very small.
yeah, but we are talking now about the neutral atom, not about any ions.
Okay, so neutral atom.
Yeah, neutral atom.
So will
Is
we
it
talk about ions later?
ions? We are not talking here. We are only dealing with nucleus. That's why
Okay, sir.
we will have ionization, uh, but ionization is not our concern. Okay, our main focus is nucleus. So you understood these three findings, right? Or three
Yes, sir.
conclusions, and you should remember
Yes,
it.
sir.
You should memorize this. Okay, these
Okay, sir.
three observations and three conclusions you should memorize. These are coming in O-level exams in
Every
structured
year.
part. Structured part either in MCQ form or in structured form. You will get it. Okay, not everywhere. Maybe this year coming, next year not coming, this year, 1 year after another, maybe coming every year. Okay, so you
Means
learn it.
90% possibility.
Yeah, there is 90% possibility. This idea is needed. You have to know it and you have to remember it. Okay, now atomic number, mass number, and nuclide notation. What is mass number? You know, right? Uh,
Yes,
in
sir.
a in an atom we have proton and neutron, right? The
Yes,
number
sir.
of protons and number of neutrons added together, that is called mass number. That is A. And atomic number of protons in atom, that is Z. Okay. And for example, here they are showing one atom as X. It can be any atom. If you
Yes,
are
sir.
talking about iodine,
Uranium, titanium,
yeah, uranium,
gold.
then iodine, gold. So any atom can be. So it's clear to you, right? Nuclide
Yes,
notation,
sir.
how it is represented.
Yes, sir.
Now isotopes and nuclide notations. So here we got one example, that is carbon.
So, what are nuclide notations?
Nuclide notations means is the notation for nucleus.
Okay, sir. I understand.
Okay, now carbon we have 12. Okay, 12 means your proton number and neutron number 12. And here we have proton number 6. So our neutron number is here 6. 12 minus 6
Yeah,
means 6.
because there is a total number of
Yeah,
protons and
isotope.
neutrons.
Now isotope means they have the same number of protons. That means they are the same element with different neutron numbers. So here
Yes, sir.
we got 14, 6. That means we have here 8 neutrons. Is it clear?
Yes, sir.
So this topic is over.
So, why did they at the end said nuclearly different means unstable?
Okay, very good. So actually this one we are going to discuss in next topic, why it is not stable, why it is unstable. However, I am giving you the idea.
Sir, a small
Look,
idea would be okay.
here we have 14, right?
Yes, sir.
That means we have two extra neutrons here.
Neutrons.
As there is difference in number of protons and neutrons, this nucleus becomes unstable. Okay, in
Reason.
reason because
The reason behind instability.
reason behind instability we are going to discuss in next topic.
Okay, sir.
Okay, because if I discuss it here, then you will uh,
Not
get
understand.
bored there. Okay,
Okay,
now
sir.
we are done with this topic.
Okay,
We are
sir.
starting the next topic. Okay,
Okay, sir.
notes on radioactivity.
Sir, may I just go and have a drink of water?
Yeah, sure, sure.
Thank you, sir.
Welcome.
Yes, sir, I'm back. Oh, sir.
Before before going to this topic, I am showing you one thing, that this worksheet already I uploaded, right?
Yes, sir.
So you will go through and you will find that,
Which one I can do?
yeah, like if I go to question number 5, hmm, yeah, the question number 4 also. The results of the alpha particle scattering experiment gave evidence for which of the following? The nuclear atom, okay? The answer
Yes, sir.
is the nuclear atom. So, question number 5. One nucleus of uranium isotope contains 238 nucleons, of which 146 are neutrons.
Means the rest are protons.
The rest are protons. Which is the nucleus of another isotope of uranium?
88 are protons.
Hmm?
88 protons. If nucleons means the mass of the atom.
88.
88 protons. If
How?
238 is the mass of the
How
atom.
88 protons?
Sir, 238 minus 146.
So how come it is 88?
Sir, 146 plus 80 is equal to 126.
No,
Oh, sorry, sir.
you subtract, then you tell me.
92, sir.
So why you said 88? I will slap you now.
Uh, sir,
Okay,
just trying to do some mental math so
okay,
that it becomes strong
92. 92.
and I
Okay.
don't become confused all the time.
Now 92 protons you have. So you have to find the isotope where you have 92 protons from this information given. Right? That one is
Yes.
isotope. So check where you are getting 92 protons.
Yes, sir. A.
Clear now?
Yes, sir.
And 6 also you can do, which are called isotopes.
Which statement about two atoms the same number of electrons in a nucleus, both are about the same number of. Sir, B.
B. So this way you will find some questions from topic 27. You will finish them. Okay.
Okay, sir.
Now we are going to notes on radioactivity. The one you asked me. Now we are going to discuss. Yeah?
Yes, sir. Sir, can we
Yes. So
extend the class time by half an hour today?
9:30.
Yes, sir.
9:30 is not possible. 9 o'clock I have another class.
Okay, sir. But sir, if any day you think that you might take, then please, because this time is
No,
from
no.
9 to 10. I am free, so you can just take.
You. Okay. Listen. You can do one thing. You can go through the worksheet. You have the time. You go through
Yes,
the
sir. I
worksheet.
just thought that if you want, you can take.
No.
Any day if you feel like you want, then you can.
Okay. Look here, origin of radioactivity. As you are saying, why it is unstable. This idea will get here. Okay.
Okay, sir.
Can you read this?
Yes, sir. Origin of radioactivity. Radio. So why did you write radioactivity 2 times? Oh, sorry, sir. Radioactive decay.
Okay.
So what is the difference between radioactivity and radioactive decay?
Okay. Radioactivity and radioactive decay is the same thing.
Okay, sir.
Synonymous. Go.
Uh, yes, sir. Matter is composed of atoms, most often assembled in molecules. At the heart of these atoms is found the nucleus, 10,000 to 100,000 smaller than the atom itself. Radioactivity is a phenomena which is produced deep within the atom. It is very same nucleus, certain unstable atom nuclei, and the source of the radiation, which distinguishes a radioactive atom from an ordinary atom.
Yeah. Next. Next. Continue. Continue.
Yes, sir. The determining factor of a nucleus stability is the competition between attractive and repulsive forces among its constituent neutron and proton, known collectively as nucleus. So, what is constituents?
Constituents means made of.
Okay, sir. Thank you.
Hmm. Then continue.
At first glance, the nuclear stability appears impossible. A nucleus contains only particles of charge, and those with no charge at all, neutrons, would not interact, as like charge repels. any nucleus should fall apart very quickly. In the fact, the reason for a nuclear stability is a strong attractive force acting over small distance in the nuclei, which overcomes the electrostatic repulsion
Okay, now
at first
hold
when
on
a
here.
steady
Look,
stability.
normally, what should happen? Normally, what should happen if some like charges are available together? They should
Yes,
repel
sir.
each other and they should go far away to each other, right? Isn't
Sir,
it?
once again, please.
Normally, uh, what is the normal rule or normal idea we have that if the charges are similar, if we have similar
They
charges,
repel.
suppose they will repel each other and they will go far away to each other, right?
Yes, sir.
As the nucleus is containing protons, we have lots of protons together in gold nucleus, for example. So it is more likely that they will repel each other and it is not possible to hold them together inside the nucleus, right? However, they are staying. However, they are staying together inside the nucleus. Why? This is because there is another force working between the protons and neutrons. There is another force is working that is called strong force, strong attractive force. What is called
Yes, sir.
strong attractive
Attractive
force,
force.
and that strong attractive force is greater than the electrostatic
Electrostatic repulsion.
repulsion force. Is it clear? And
Yes,
that
sir.
is the reason that so many protons which are positively charged, they are staying together inside the nucleus because the strong attractive force is overcoming the electrostatic repulsive force. Is it clear?
Yes, sir.
Okay, so this is very important. If you want, you can also write it on your copy because this is very important. You are not taking the printout, you will not find it where it is written.
I know, sir. I'm going to take it out.
Is it clear?
Yes, sir.
Are you writing?
Sir, then I need to get a copy now.
Yes, you write it. If you write it, then you can remember it easily. Strong attractive force is coming from the attractive force of protons and neutrons in nucleus.
Done, sir.
Did you write?
Yes, sir.
So what you wrote? Can you tell me?
Sir, the thing which you just said, strong attractive force overcome the electrostatic repulsion.
Yeah. And because of this reason, positively charged protons can stay together inside the nucleus.
Okay, sir, just 1 minute.
Because of this reason, positively charged protons can stay together in nucleus.
Yes, sir.
Then next, read.
A third force, which weak nuclear force, is also present in the nucleus, which adjusts the neutron proton ratio so as to
Neutron
maximize
proton
the
ratio. Neutron proton ratio. This way read. The third force, weak nuclear force, that is adjusting the neutron proton ratio. Okay.
yes, sir.
Okay. Continue.
So neutron proton ratio.
Hmm.
So as to maximize the energy binding them together. Too many or too few neutrons makes the nucleus unstable. As unstable nucleus eventually decays, emits alpha and or okay, I understand. Alpha and beta particles, gamma radiations, and this process is called radioactivity.
So you understand why the nucleus becomes unstable. Why the nucleus is
Because
giving,
there is too many or too few neutrons in the nucleus.
like carbon 14, it has two neutrons extra, right? And
Yes, sir.
the nuclear force, weak nuclear force wants to balance this ratio. Okay. The weak nuclear force is staying in the nucleus. That one wants to make number of protons and neutrons equal. Okay, is it clear?
Yes, sir.
So you write this note that weak nuclear force tries to balance number of protons and neutrons in a nucleus.
So could you repeat?
Yeah, weak nuclear force wants to or tries to balance number of neutrons and protons in a nucleus.
Yes, sir. Wants or tries to.
Yeah, you can write anything. Wants or tries to balance number of neutrons and protons in a nucleus.
Yes, sir.
Now, look, an unstable nucleus eventually decays. That means, because of this weak nuclear force, if the number of protons and neutrons they are not equal, then what will
Yes, sir.
happen? The nucleus become unstable. Okay, nucleus becomes unstable and it decays alpha, beta, and gamma radiations. And this process is called radioactivity.
Yes, sir.
Is it clear?
Clear, sir.
Okay, now I'm giving you one example. That one already you know about carbon 14, right? From there, I'm
Yes, sir.
taking this example. Like carbon 14, already you know that it has carbon 14. You write, huh? Carbon 14, 6. Here we have two neutrons extra, right? I'm writing in text here. Two neutrons, two neutrons extra. That's why it becomes unstable and shows radioactivity. Okay, how it is showing radioactivity? I'm giving you now that example. You see, there is two neutrons extra, right?
Yes, sir.
So, and these two neutrons, one of the neutrons will break down this way, and I'm writing this way. Mm, okay, so one of the neutrons has mass 1, right? And no charge. This neutron breaks down. This neutron breaks down and produce one proton. Proton has one positive charge and mass is 1.
So one proton and one electron.
Yeah, one proton plus one electron it
Sir,
produces.
so is it true that neutrons are made from electrons and protons? Means the
Like that,
combination of
like
electron and
that,
proton.
like that. Okay, now look, here we have the electron with -1 negative charge and it does not have any mass number because mass number we are considering for those which are staying in the nucleus. Okay, proton has one mass number and neutron has one mass number. Uh, look, here we have one proton number, right? Extra.
Yes, sir.
So carbon is no more carbon. Now it's if you are changing proton number, then it's
It
having here
will become
7.
oxygen or further.
Yeah, it will become nitrogen, right?
Yes, sir, nitrogen.
Now it will become nitrogen 7 and nitrogen 7 has mass number 14, right?
Yes, sir.
So look, the mass number remains same. One neutron breaks down to one proton, right? Hello. So you are losing one mass and gaining another mass, right? That's why the mass number remains same. Is it clear?
Yes, sir.
Uh, and this electron we are getting, this is known as beta particles.
So so neutron and proton are known as alpha particle. Means if they are together,
Two neutrons and two protons together, that is known as alpha. And
and one
only
electron is known as beta.
beta. And gamma radiation is electromagnetic wave. It is happening for other reasons we will discuss later. Why it
Yes, sir.
is. Now at least you understood that how the instability comes and how it is balanced,
Yes, sir.
right? And as it is emitting beta particles, that's why we are saying this one is showing radioactivity because
Okay, sir.
beta particle it has some ionization power, it has some speed which can penetrate through plastics or our skin. Yeah. So beta particles have some radioactive property. Is it clear?
Yes, sir.
No. So you understood your question. You asked me in last topic. You got your answer right.
Yes, sir.
Now you are happy.
Yes, sir. Satisfied.
Okay, satisfied, mashallah. So now we are going for more details. We have the idea of origin of radioactivity, and we understood how it is happening. We understood what is called a strong attractive force, which one is weak nuclear force, and what is the purpose of weak nuclear force. We got that one. Okay, now we are going to our next discussion. Yeah, these
The
are
last
actually,
discussion for today.
yeah, these are actually the summarization of our discussions already we got. Can you read this?
Yes, sir. The strong forces hold atomic nuclei together, and the weak force causes radioactivity decay. The strong nuclear force is responsible for binding protons and neutrons together in an atomic nucleus. It is stronger and short range and have to overcome electromagnetic force. স্যার আমি একটু আবার পড়ছি মানে অত
Ye-
বুঝতেছি না বলে
Yes, yes.
The
Please.
strong force holds atomic nuclei together and the weak force causes.
Radioactive decay.
Okay.
So,
Yes,
so
sir.
this sentence you understand. Then you go to next sentence.
Okay, sir.
Is
The
it
weak
clear?
force means the repulsive weak force, isn't
No,
it, sir?
no, no. Weak force balances the neutron-proton ratio. Just now we discussed. It wants to balance neutron-proton ratio.
Okay, sir. Hmm. The strong nucleus force is responsible for binding proton and neutron together in an atomic nucleus. It is talking about the strong attractive force, right, sir?
Yes, 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 yes.
It is strong and short-ranged and has to overcome the electromagnetic force which is pushing positively charged proton apart.
Clear
Hence, it
this
is
one?
stronger.
This
Yes,
part is
sir.
clear?
Yeah.
Then you go
Yes,
to
sir. The
next.
attractive force is much more stronger than the electromagnetic force.
That is the repulsive force we are talking about, right?
Yes, sir.
Electrostatic repulsive force, that is also known as electromagnetic force. That's it. Then next.
Okay, sir. The nuclear force is responsible for radioactive decay by being able to convert a proton into a neutron or vice versa.
So is it clear? The weak nuclear force
Nuclear force is responsible for
is
radioactive.
balancing the number of proton and neutrons, right?
Okay, sir.
Just now we had idea how the number of neutron is converting to proton and electron,
Sir,
right?
what are these links for?
This list for some videos in YouTube where you'll get more ideas about strong force, weak force, and all kinds of forces.
Okay, sir.
Is it clear?
Clear, sir.
Okay, now they said about vice versa. Vice versa means in
Like we
carbon,
saw over
yeah,
here.
in carbon 14, you got two neutrons extra, right? That's why we are getting here neutron converts to proton and electron. But there are some nucleus or there are some atoms, there are some elements where you will get proton numbers more than neutron numbers. Are you getting me what I'm saying?
Yes, sir.
So in that case, what will happen? Proton will break down. Okay. If the number of protons are more, than proton will break down to neutron and positron. Is it clear?
Yes,
You
sir.
you will not get this discussion in O level. We have this discussion in A levels. The vice versa one will get in A levels. Okay, but I just gave you one hint. At that time, Proton will break down and it will convert to neutron and positron. Positron is opposite of electron. Is it clear? Hello?
Yes, sir.
It is subatomic particles and it has opposite charge of electron. Okay. Then we are going to random emission of radioactivity in direction and time. This one also we'll do today. Random emission of radioactivity in direction and time. Can you read this?
Yes, sir. Random emission of radioactivity in direction and time. All nuclei of a radioactive substance have the same probability of undergoing radioactive decay. Emitting alpha or beta particles and or gamma radiation, it is not possible to tell which nuclei will be in the line to decay or how long it will take to decay.
Okay,
Since
so
it is independent.
this part you understand, then go to next. Okay, all the nuclei of radioactive substance have the same probability of undergoing radioactive decay. So all the nuclei of a radioactive substance, like you are taking uranium, right?
Yes, sir.
You are taking uranium sample. That one has, for example, 2 millions of uranium atoms. Okay,
6.02 into 10 to the power 23.
okay. So if you have this amount of nuclei, then you you don't know out of these 2 millions which one will decay first. Okay, so this one is called random in direction.
Random in direction.
Yes, random in direction. That means you don't know which one will show the radioactivity first. This is random in direction. Okay, now another thing that told that is, it is not possible to tell uh, how long it will take to decay. If it is not possible to say how long it will take to decay, then it is called random in time. Radioactivity is random in time.
Okay, sir.
So is it clear
Understand,
that
sir.
random
Means
and
when we don't know which one will decay first, it will be
that
random
is
in
random in
direction,
direction, and how
and
long
how
it
long it
will
will
take
take
we
will be
don't know, that
random in
is
time.
random in time. So is it
So
clear?
why is there random in time? Because aren't means as we know that there is difference in uh, means there are different atom means they are the same atom but are isotopes.
Yeah, they
So
are isotopes.
one of them
Even
have this.
we are saying the same isotope, like they are carbon 14 only. Okay, maybe there are
Yes, sir.
thousands of carbon 14, but this is their nature. That one of the carbon atom, carbon 14 atom, it will decay earlier, and one will decay later.
Is there a specific reason, or we
This
don't know the reason
specific
yet?
reason means like when they are staying together, there are lots of issues. Now we are only starting nuclear physics. We are knowing some of the things, like we just today knew about strong nuclear force. We just
Yes,
today
sir.
knew about weak nuclear force, right? But where from all this coming? We don't know all these things still. We have lots of subatomic particles inside the nucleus. We have bosons, we have mesons, we have positrons. So all these things they have some effect on this process in this nucleus radioactivity. But we are now only focusing on the main things which are responsible for decay. That's why it's
Means first we
happening.
will study the center, then the surrounding.
Yeah. So you just now only focus here that it will not take same time.
The same time for every
Yeah,
isotope or
yeah.
every radioactive
That
particle.
is random in time, right?
Yes, sir. Since it is independent of external condition and the
Yes.
breakdown within the nucleus is completely random.
Yeah.
Example, occurrence of radioactive emission is random over space and time.
So
Means,
down, right?
yes, sir. So, what is random over space and time?
Same thing. You see, space means they are staying together, right?
Yes, sir.
So they are
Means which
staying
one
together
will
means
go first?
one has distance from another one that is random over space. Okay,
Okay, sir.
so which one it will decay next? We don't know. That is related to random over space. They are saying random over direction. That one is meaning random over space. Is it clear?
Yes, sir.
So we are done till here, and you try the worksheet as much as possible. Okay.
So we still have time, sir.
We
We have
have
still five
five
minutes, sir.
minutes. That one you
Yes,
want
sir.
to continue. Actually, we
We
are
can
going
finish the
to have
detection of.
we are going to have this one new detection of radioactive emission is a big one. We have lots of. That's why
No, sir. Till the first talk, the starting,
yeah,
sir.
we have here all together discussions still here. That's why I did not want to start. Rather, you 5 minutes you concentrate in solving worksheet. Okay,
Okay,
that
sir.
will be better. Once we start it, we will finish it. Otherwise,
Okay, sir.
there will be uh, problems. That means there will be some feelings of incompletion in your mind that might affect your learning process. Okay.
Okay, sir.
Now we stop here. Okay. Allah Hafiz. You try
Okay,
to
sir. Have a nice day.
read out by yourself the whole notes. Okay. Try to
Yes,
read
sir.
out the whole notes by yourself and try to solve the worksheet as much as possible. That will make me more proud, okay? More satisfied. Allah Hafiz.
Okay, sir. Have a nice day. Assalamu alaikum.
Walaikum salam.